In this chapter, we will be studying rational expressions. In this lesson, we'll look at multiplying and dividing rational expressions. Okay, everybody. So in this lesson, we're going to look at multiplying and dividing rational expressions. So we're going to do really just a whole bunch of examples. Okay, but to start off with, here's the pattern we're going to follow. First of all, we're going to factor. Anytime that we see expressions that we can factor in the numerator or the denominator, we are going to factor them because we can cancel, okay, we can cancel factors from the numerator to the denominator, right? Now, if you've got factors that are the same in the numerator and the numerator, like if they're both in the numerator, well, you can't cancel them. They multiply together. But if you've got a factor in the numerator and it's also in the denominator, then we're going to use that division to become a 1. Okay, and that's going to be our reducing there. We're going to identify all the non-permissible values. Now, this becomes particularly important when we're doing division. Okay, and we're going to take a look at some examples so you can see what's going on there. We're going to reduce complete factors. Okay, that's what we're talking about here. Then we multiply straight across. And if we're dividing, remember that we have to flip. Okay, or what we do is we multiply by the reciprocal. And I'm finding that there's more and more students that are having difficulty remembering which one to reciprocate. It's the reciprocal of the divisor, what it is you're dividing by. Okay, so we're going to multiply by the reciprocal of the divisor. That's going to make that a little bit easier for us. So now what we're going to do is just going to do a whole bunch of examples, and hopefully by the time we're done going through all those, you'll have a really good sense of the pattern and the rhythm of it. Okay, so let's take a look at this first problem here. So the first thing we would want to do normally is factor. But when we say factor, we're typically referring to polynomial expressions that can be factored. And there are no polynomial expressions here that can be factored nicely. However, we also want you to be thinking about the numbers and how they could be factored. So for example, I'm seeing 5 here. Well, 5 is prime. I see a 2, 2 is prime. But the 8, okay, 8 has a factor of 2. And 15 has a factor of 5. So I'm paying attention to the composite numbers, the coefficients that I'm seeing there, and how they can break apart. Now, I want to identify my non-permissibles here, okay? Right from the get-go, what I want to do is I want to look at my denominators here and figure out, are there any values for the variables that would cause me to divide by 0? Because I don't want to do that. And what I'm seeing here, yeah, a couple examples here. Y. I have 2 times y right here. Well, if y is equal to 0, then 2 times y is 0, and I'm dividing by 0, and I can't allow that. So I can't allow y to equal to 0. Same thing over here for the x squared. I can't let x go to 0. If x goes to 0, then x squared becomes 0, so does 15 times x, and then I'm dividing by 0, and I can't allow that. So I can't allow that to happen. So those are my non-permissible values here. Now what I'm going to do is I'm going to multiply straight across here. Okay, but what I'm going to do is I'm going to bring my coefficients together, and I'm not exactly going to multiply them together. I'm going to write them as if they're multiplied together. So I'm going to write the 5 multiplied by the 8 x cubed y over 2 multiplied by the 15 x squared y. And yeah, I'm changing the order a little bit because I have the freedom to do that. Order doesn't matter with multiplication, so I'm moving the y to the back. It just looks better when the y is at the back here. And now what I'm going to do is I'm going to start to divide. Now, the nice thing is about multiplication and division, they're very, very closely related operations. Okay, and as long as I'm careful with how I organize it, how I structure it, I have a little bit of freedom in terms of the order that I can do those in. So I can start to divide right now. So for example, I've got a factor of 5 here, and I can divide that with the factor of 5 that's in the 15. That will leave me with a factor of 3 left over. There's a 2 here. There's a factor of 2 in the 8. That will leave me with a factor of 4 left over. So my final answer here is going to have a 4 in the numerator and a 3 in the denominator. Now, I've got x cubed divided by x squared. So in other words, I've got 3 factors of x in the numerator, x times x times x, and I've got 2 in the denominator, x times x. Well, I can pair up each of those 2 factors in the denominator with a factor in the numerator, and those will cancel. X over x cancels. X over x cancels, and what's going to happen here is I'm going to be left with a single x left over in the numerator. And then y divided by y is just 1. And so that particular factor disappears. So here's my answer, but I drew the line a little long and it's a little wonky here, so I'm just going to write it out again. Okay, 4x over 3, where x can't equal 0 and y can't equal 0. Now, I realize that in the final expression of my answer, well, there is no x in the denominator. There is no y in the denominator, so why are those restrictions there? Well, it's because those restrictions were present at the very beginning of this problem. Those restrictions are present here. And I want each step along the way to be equivalent to the one above it. I want them all to be equal. So when I did my canceling here, okay, I eliminated the issue, really. I eliminated that issue of division by x. I eliminated the issue of division by y. But because that was present in the original question, that restriction was there, and so I have to include it at the end. I can go from here to here as long as I never let x go to 0 and I never let y go to 0. And y doesn't even show up in the final answer. Looks a little goofy, but that's the way that works. I cannot go from here to here unless I make sure that that is true. All right, now let's take a look at this one. And this here is a division statement. Okay, so once again, first of all, we're going to look at factoring. And there's no real polynomials here that require factoring. There is a little expression here that we might want to deal with, this 2a squared. Okay, we might want to just write that as 4a squared, just to make our lives a little bit easier. But that's about as much as we can do. Now, I'm going to take a look at my non-permissibles, and I notice that I've got a b in the denominator and another b over here. So what that means to me is I cannot allow b to go to 0. And that's because b is a factor. It's not just its presence in the denominator that requires me to say that b can't be 0. It's because b is a factor all unto itself in the denominator. And I can't allow that factor to be 0. Okay? Now, first thing I'm going to do is my division. I'm going to let that division become a multiplication by multiplying by the reciprocal of the divisor. So I'm going to have negative 4a cubed over 3b, and we're going to multiply that, and I'm going to reciprocate this by 3b squared over 4a squared. Now notice, as soon as I did that, I've now got a different denominator, which means I can introduce another restriction, and in fact, there it is. I can't allow the a to go to 0 either. Okay? If at any step along the way I end up with a restriction, well, that restriction is there and influences the final answer, and so I have to acknowledge that as I go from here to my answer, I'm walking through these restrictions here. So I need to state those. Now, just in the interest of space here, I'm going to start to cancel factors. Now, I could, like I did in the previous question, write them all together here, but because I've got it as division, I already know that I'm going to write this one up against this one, write this one up against this one, and then I'm going to start to cancel factors. So I'm just going to start to cancel those factors now that I see. I have a 4 in the numerator and a 4 in the denominator, so those are going to cancel. Now, bear in mind that there is a negative there, so I'm still going to have a negative 1 here. I've got a 3 in the denominator here, a 3 in the numerator, so 3 divided by 3 is 1. So that's going to go away. And now I've got 3 factors of a in the numerator and 2 in the denominator. Okay, so another way I can think about this is remember, when you're dividing powers, you can subtract exponents, and so 3 minus 2 is going to be 1. So I'm going to lose that, and I'll be left with a single a in the numerator. And actually, I get basically the same thing happening here. I've got 2 b's in the numerator, 1 b in the denominator there, so I'm going to lose one of those, and I'll be left with 1 in the numerator. So what I've got here, when everything is said and done, I've got a negative 1, a, b, with the stipulation that I cannot allow a to go to 0, and I cannot allow b to go to 0. Okay, and those restrictions are not obvious in the final statement of the problem. When I look at this, I can't tell that a can't be 0 and b can't be 0. That answer doesn't tell me that. It's the work that I had to get through to get there that brought up those restrictions. Okay, now we're going to take one that's now got some polynomial expressions in it with a little bit more meat on them. Okay, we're not looking at monomials anymore. So now we're going to factor the numerator and denominators. Okay, So now we got a little bit of work to do. So notice in this first numerator I have a common factor of 3. And in the denominator I've got a common factor of 2. Up here I've got a common factor of 5. Actually, I shouldn't have written it like that. There we go. And then down here I've got a common factor of 6. Okay. Now I'm going to take a look at my non-permissibles. And in this case right now, I can more clearly see what my non-permissibles are because I did myself the favor of writing it in factored form. I've got these two binomials here. Notice that x is not alone as a factor. Okay? I have to put brackets around it. It's together with this 1 here. It's a binomial. Okay? That's a binomial factor here. Now, that binomial factor won't go to 0 unless x is -1. And so I cannot allow x to equal -1. Now at the same time, I've got this binomial factor in it with an x in it. And I can't let this binomial factor go to 0, which means I cannot allow x to also equal +1. Either -1 or +1 is going to cause me a problem in this particular question here. Now, I could multiply across here, but I already know that when I do that, I'm going to end up with factors in the numerator, factors in the denominator that I can cancel here. I have got, for example, a factor of 3 up here and a factor of 3 here in the 6. That's going to leave me with a 2. Now notice that the 2's do not cancel. They're both in the denominator. In fact, I'm going to multiply them together. My factor, my coefficient here of 5, there's no corresponding factor in the denominator for me to cancel that with, so it stays. Now, I've got an x plus 1 in the denominator and an x plus 1 in the numerator. Those will cancel. X plus 1 divided by x plus 1 is 1, as long as I don't allow x to equal -1. I've already said that. X minus 1 divided by x minus 1 is 1, as long as x is not allowed to be +1. And so now when all is said and done, all that kind of survived in my numerator was the 5, and all that survived in the denominator were these two factors of 2 to give me 4. So this expression here is equal to or equivalent to 5/4. I can make it equal, exactly equal, as long as I throw that restriction in there where x cannot equal -1, x cannot equal +1. Do you have to write those restrictions with the answer, or can you just leave them up here? I would suggest you write them with your answer, okay? So that you communicate to your teachers that you know that this expression is equivalent to this as long as we've kept this true, okay? Anyway, hope that helps. Let's do. Okay, let's try another one. So first thing we're going to do here, because we're seeing that we've got some polynomials here. Let's see if we can factor that. In the numerator here, I've got a common factor of 4, so it's going to leave me with 4 times n plus 2. Down here, I'm going to have a common factor of 3 divided by, I'm not going to deal with the division quite yet. I'm going to factor here first. Take out a 2, m plus 3, then take out the 7, n minus 1. Now, normally what I would like to do at this point here is in the dividend and then the divisor here, what I'd like to do is simplify if I can, if there's anything that's common that I can cancel. But there isn't. In either one of those, there isn't here. So I'm going to take a quick look at my non-permissibles here. And in both cases here, I'm just seeing that n cannot be equal to 1. If n is equal to 1, I get 1 minus 1 goes to 0. So there we start off with n cannot equal 1. Now I'm going to take and rewrite this division as multiplication by the reciprocal of the divisor. So 4 times n plus 2, 3 times n minus 1 multiplied by 2 times n plus 3. Wow. I said it and then I didn't reciprocate it. Sorry about that. Don't know where my head went for a second there. Here we go. 7 over n minus 1 all over 2 times n plus 3. Now, just like in a previous question, I've changed the denominator a bit. And so now what that means is I've changed, or I've at least introduced a new restriction here. M cannot be equal to negative 3. If m is negative 3, okay, if m is negative 3, then this term here goes to 0, and I can't allow that. So I can move to this spot right here as long as those two restrictions are kept true. Now, I'm going to take things that I see in the numerator and the denominator, they're the same, and I'm going to cancel them out here. So 4 has a factor of 2 in it, so that 2 is going to disappear, and I'm going to be left with a factor of 2 up there in the numerator. Well, there isn't much else here. The n minus 1 and the n minus 1 become 1, so long as n is not allowed to equal positive 1, and I've already identified that. There's no other shared factors, numerator, denominator. That m plus 2 and the m plus 3, they're not the same. They're a little different here. And so what I'm left with here is 2 times 7 in the numerator, so 14, multiplied by m plus 2, over 3 multiplied by m plus 3. Okay? Now, there's really not much else I can do here. Sometimes what you're going to see, and I'm going to do this, it's not always necessary, it kind of depends on who your instructor is, but often you're going to see that what we get people to do is we get people to expand the numerator. Okay? So we're going to multiply the 14 through, but we will typically leave the denominator factored, and there's a reason for that. So this could be just one step of a larger problem where maybe we have to add and subtract fractions or expressions here, rational expressions, whatever. Sometimes it helps to expand that numerator to be able to put things together. However, the denominator is usually more useful to us when it's factored because I can find common denominators easy, I can identify non-permissibles easy when it's in this form. So you just got to figure out which of these two forms is required there. But remember, that's only true so long as n is not equal to 1, and again, m is not equal to negative 3. And again, I know that looks weird because there isn't even an n in the final expression here. But it was a step along the way, and it was a restriction that popped up, and so we must include it, okay, in order to maintain equality from the question down to our answer there. All right, now this question's got a little bit more going on because there's a little bit more interesting factoring going on here. Okay, so take a look here. M cubed plus 3m squared. Well, I've got a common m squared to both of those terms here. Remember, when I'm looking at the exponent, I'm going to take the smallest exponent that I see there, okay, because that will be what's common, what's shared amongst all those terms. The denominator, this is a fun one. M squared minus 9. Okay, this is a difference of squares here. And remember, that factors like this. M minus 3, m plus 3 into binomial conjugates. Okay. Same expression, just different signs. Here, up in the numerator, I've got an m squared and an m. Okay, so m's in both those terms, but the smallest exponent on there is 1. Okay, remember, if you can't see it, it's still 1. So I'll pull that out, and I'm going to be left with m minus 3. And then m squared, there's not much I can do with m squared. It's m squared. So it's nicely factored here. Factoring allows me to see the non-permissibles much, much easier. So I'm just going to run through all the places where I see that variable in the denominator here. So here I see it locked into a binomial factor, m minus 3. Well, I can't let m minus 3 go to 0, which means I cannot let m become positive 3. But I've got an m locked in another binomial. M plus 3 can also not equal 0, and which means I can't let that m become negative 3. And then over here, because m shows up essentially by itself as a factor, as a factor twice there, as a matter of fact, I cannot allow m all on its own to become 0 because that will cause division by 0 right here. So letting m go to 3 causes a 0 here. Multiply that, the whole thing comes to 0. If you let it become negative 3, this becomes 0, the whole thing becomes 0. And even if you let it become 0, the whole thing becomes 0. Now, let's start canceling common factors. And this is beautiful. I've got this m squared, that becomes 1 so long as we don't let m go to 0. Because 0 divided by 0 is not 1. M plus 3 divided by m plus 3 is going to be 1 so long as m does not equal negative 3. And then m minus 3, numerator denominator, becomes 1 so long as m does not equal positive 3. And in fact, so much disappeared here, it turns out I'm only left with m. So that expression really is equivalent to the letter m all by itself, the variable m all by itself, so long as m at no point becomes 3, negative 3, or 0. Right, in this next question, actually in this next question, I'm going to encourage you to do a little something here to change the question just a little bit before you get into it. What I'm going to get you to do here is change the part of the problem that's not super pretty. And when I look at this problem right here, what I'm seeing here is everything looks good except for this 16 minus a squared. I don't really like that. Okay, there's nothing wrong with it. Please don't misunderstand me here. It's just that is an odd way of writing that. Normally what we would do, and I'm just going to deal with this right off the bat here. Normally what we would do is we would write that with the a squared first. So I'm going to treat this as if it's adding negative a squared, and I'm going to switch the order of those two terms. Okay, and I can do that. And remember, order doesn't matter for addition, and I have interpreted that subtraction there as adding a negative, and I can do that. Now, that's great. I can make it just a tad prettier, though, by factoring the negative out of this denominator. Okay, that negative right there. So what I can do here, and I know I'm putting a bunch of effort into this, and probably going to run out of room here in a bit, but anyway, I'm going to take that negative out, and that's going to become a squared minus 16. And then what I'm going to do is I'm going to move that negative, and it's because I'm allowed to do that. I'm going to move that negative up to the numerator. Okay, and I'm totally allowed to do that. Okay, if I've got negative 1/2, that is the same as negative 1 divided by 2. That is the same as 1 divided by negative 2. Okay, I am free to move that negative wherever I want here. However, I am not free to distribute the negative to both the numerator and denominator. Negative 1/2 is not the same as negative 1 over negative 2. Those negatives would then cancel to create a positive fraction. So don't do that. But I can move that negative up there. Now what I'll do is I'll factor. So a plus 4 really can't be factored. With a squared minus 4a, there is a common a there. It'll be a minus 4. And then a squared minus 16 is a difference of squares. That will be a minus 4, a plus 4. All right. Now that I've dealt with that denominator, or the factoring there, now I can identify the non-permissibles, and right off the bat I can tell you that because a shows up as a factor all by itself, a cannot be 0. And then I've got this factor right here that a is locked up into, this binomial factor here, a minus 4. Well, I can't allow that to go to 0, which means I cannot allow the value of a to be 4. There's repetition right there of that factor, so I have the same non-permissible, okay, 4. And then over here, a plus 4, I can't allow that factor to go to 0, which means I cannot allow a to become negative 4. Good. Now I'm going to deal with the division by multiplying by the reciprocal, and that will be a minus 4, a plus 4, all over negative 1. Now, in this particular case here, this did not introduce any new restrictions because I didn't end up putting a variable into the denominator. Okay. In fact, I moved that variable a up out of the denominator. But remember, that doesn't get rid of the restrictions. If the restriction shows up at any step, it's part of the problem. So now let's start getting rid of shared factors here. There's an a minus 4 and an a minus 4. I can get rid of those so long as a does not equal positive 4. And that's it. That's all there is. This a cannot cancel with that a because this a down here is a factor all by itself, but this a is part of a binomial factor. Okay, so this a is part of a bigger expression than this one is. They don't cancel. Now, what I can do is multiply straight across, and I will get a plus 4 squared. And then in the denominator there's a minus a, negative a. And that might be enough. You might find that you're asked to move that negative up. That does look a little bit better. And you may even be asked to expand that a plus 4 squared. So that could end up becoming a squared plus 8a plus 16 all over a, with the restriction that a cannot equal 0, 4, or negative 4. Now, there might be a question that pops up, where did that 8a come from? Okay, where did I get the 8a? Well, when you squared a plus 4, remember that means a plus 4 times a plus 4. And when you multiply two binomials together, every term in this binomial gets multiplied by every term in this binomial. So the a gets multiplied by a squared. The a gets multiplied by 4. Then this term gets multiplied by every term over here. So 4 times a is 4a. 4 times 4 is 16. So a squared, there are now 8 a's there plus 16. And that's where that 8a came from. Okay, so there you go. Okay, for this one right here, let's take a look at the factoring. Now, this is because everything here looks pretty, by the way. There's nothing kind of backwards about the way that's written. We start with n in every case here, and I like that. Let's start with the factoring here. So in this first numerator, I've got a common factor of 3. I like that. Oh, look at that down here, 3n plus 2. You know, there is no common factor. That is as good as that's going to get. Divided by n plus 2. Now, n squared minus 1 is a difference of squares. That's going to be n plus 1, n minus 1. Okay? Now that I've got everything factored here, I'm going to identify non-permissibles. This is an interesting one here. Okay? Because I've got that 3n plus 2, this is a little bit more complicated. Let's just take a quick look at that. What this means here is I cannot allow 3n plus 2 to become 0. Okay? I can't allow that to happen, which means, and I can work with this just like an equation, I cannot allow 3n to be negative 2, which means I cannot allow n to be equal to negative 2/3. N cannot be negative 2/3, so there's a restriction that comes from here. From here, I can't allow n to be equal to negative 1. Additionally, I can't allow n to be positive 1. Those don't work. Now, I'm going to multiply by the reciprocal of the divisor, and this will be n plus 1 and minus 1 over n plus 2. And what that has done is actually has introduced a new non-permissible, okay? Because I've taken that expression there, that n plus 2, put it into the denominator, so now I can't let n plus 2 go to 0, which means in addition to this, I should say up here, I can't let n be equal to negative 2. Now I'm going to cancel factors, and notice what's going on here. And this was done on purpose. Okay, this was done very much so on purpose. These do not cancel. They are different. Here, the n is being multiplied, the 3 is being multiplied by the n only, and then we add 2 to it. Here, we're adding 2 to the n first, and then multiplying the result by 3. That's very different. These do not cancel. Okay, they don't become 1. But there is an n plus 2 here and an n plus 2 here, and those will cancel. You might think, well, then do those two 3's cancel? And no, they don't. No, they don't, because that 3 is locked in to a binomial factor. That 3 stands on its own. It is 3 being multiplied by a bunch of expressions. Here, you might say, well, isn't the 3 being multiplied by n? And that's true, but then that term is being added to a different term. Oops, sorry about that. And so now we're going to move forward here. We've canceled those out. Again, like I said, we can't cancel those 3's out because that 3 is locked inside a binomial factor. And it turns out we can't really do much with those either. So we're at the point here where we're going to expand things out, or we're going to multiply things out, I should say. So it'll be 3 times n plus 1 times n minus 1 over 3n plus 2. Now, if this is where I was going to end it, I would write my non-permissibles there, but in this particular case here, I'm actually going to multiply that difference of squares out. Now, I factor the difference of squares up here because I'm kind of hoping that something will cancel when I do that. But in this case, nothing did. So, but I like having the difference of squares multiplied out. Okay, so when I multiply n plus 1, n minus 1, I'm going to get n squared minus 1. I like that. That looks so clean. Okay, and now I'm going to multiply that 3 through to get 3n squared minus 3 over 3n plus 2. And now, where n cannot equal negative 2/3, negative 1, 1, and yoink, negative 2. Now, there are going to be people that really do prefer to have everything written in factored form, and there are going to be people who really prefer to have that numerator expanded out. Most people will typically agree that we like to have the denominator factored. It's just convenient. So you just got to kind of work that out with your instructor as to what the expectation is. Anyway, hope that makes sense. Right, so this next question, actually things take a little bit of a turn towards the easier here. So we've got a bunch of binomials here, but they're all factored, okay, or at least they're all as simple as they're going to get, is what I should say there. Let's take a quick look at our non-permissibles here. Notice it's multiplication, so I don't even have to worry about reciprocating the second term here, the second factor. Okay, I cannot allow x to be equal to negative 2, or here I can allow x to equal positive 3. Those will both lead me to division by 0. Now, I've got shared factors, two binomial factors, okay, one in the numerator, one in the denominator. They're going to be the same. And so now when I just multiply the factors across, I'm just going to get x over x minus 3. And then that's as good as that's going to get. I can't cancel the x's because remember, x here is not a factor. X up here is a factor. All by itself, it just sits there, it's a factor. But here, x is locked into that binomial. It's part of that binomial factor, so I can't cancel it. But now I will identify the non-permissibles again. So this expression is equal to x over x minus 3 as long as x cannot equal negative 2 and x can't equal positive 3. Okay, so for this problem, let's take a look and see, is there any factoring we can do? Yeah, just not a lot. So x plus 3 is as good as it's going to get. So is 5x minus 1. Because that 1 there is that prime factor. Divided by, well, there's a common factor of 2 in that binomial over 4x. That's as good as it's going to get. Now, let's take a look at our non-permissibles. Can't allow x to be. Now, well, let's take a look at this one first here. Because x is a factor by itself, it's being multiplied by 4. It's not being added or subtracted to it. It's being multiplied. I can't allow x to go to 0 there. Now, over here, it's locked inside a binomial factor here, so I cannot allow 5x minus 1, can't allow that to go to 0. Which means I cannot allow 5x to be equal to positive 1, which means I cannot allow x to be equal to 1/5. So, can't be 0, can't be 1/5. Now, I'm going to take a quick look here. Is there anything I can simplify before I even do the division? The answer is yes. It's not a huge simplification, but there is a factor of 2 there and a factor of 2 there that I can cancel. It's not as great as I would like it to be, but that's okay. Still, it's a step forward here. So now I've got x plus 3 divided by 5x minus 1. I'm going to change this to multiplication. Now it's going to be 2x in the numerator over x plus 3. I have now got a new binomial in the denominator, and that brings with it a non-permissible. I cannot allow x to be equal to negative 3. Okay. And now let's see if we can cancel anything here. Well, we've got an x plus 3 in the numerator, x plus 3 in the denominator, so those two binomial factors will divide out, become 1. And although I've got an x here and an x here, remember, this is a factor here. That is locked into a binomial. Okay, it is a factor when it's multiplied by 5, but then that is, I'm subtracting 1 from that. And that is all together as one binomial factor, so I can't cancel those. That is as good as that's going to get. And so this becomes 2x over 5x minus 1, and that is true so long as x is not allowed to equal 0, 1/5, or negative 3. And actually, you know, probably should have said this before. You're probably going to have some teachers out here that really want you to write those restrictions all the way through. With every step along the way that you do, they're going to want you to write that. You're really going to have to get a feel for what is being expected of you as you go through and do this work. All right, let's have a look at this next question here. And let's do some factoring first of all. So in the numerator, I do see a common factor of x. Oh, and then in the denominator here, love seeing those difference of squares there. So it's going to be x minus 2, x plus 2. Remember, that's x squared minus 4. So I'm going to do square root minus square root plus square root. Divided by, and then over here, no, those are as good as those are going to get. There we go. So now let's identify our non-permissibles up here. So we know that x cannot equal, and I just kind of slide along here, can't be equal to 2, can't be equal to negative 2. Oh, and then I see that repeated, can't be negative 2. Now, I'm going to look at my individual little pieces here, my dividend and my divisor. Is there anything here that I can simplify before I go on? Nah. And there's nothing over here I can simplify. Okay, so I'm just going to move forward here. We're going to multiply by the reciprocal of the divisor. Okay, so there we go. So x plus 2 over x plus 3. And notice that this has introduced this new binomial into the denominator here, which means my non-permissible has changed just a little bit. I have to include negative 3 in there. Can't allow x to be equal to negative 3. Now let's see if we can cancel here. Well, I've got an x plus 2 in the numerator and the denominator. So those will become 1. X plus 2 divided by x plus 2 is 1, as long as x does not equal negative 2. X plus 3 divided by x plus 3 is 1, so long as x does not equal negative 3 at any point there. And actually, that's kind of a beautiful thing, because now all of a sudden we're down to this right here. Bear in mind, I cannot cancel those x's. X sits by itself as a factor up here, but this x here is together with that negative 2 as a binomial factor. Can't be separated. So there we go. So there's my answer, as long as we state that x cannot equal 2, negative 2, or negative 3. All right, now this one here, and let's take a look at any factoring we can do here. Okay, well that up there, that is a difference of squares. 4x squared minus 1 is going to be 2x minus 1, 2x plus 1. All over x plus 2, that's as basic as that's going to get. Divided by, okay, up here I've got a common 2x, so that'll give me 2x plus 1. And down here, okay, well I've got a common 8. Now, when I take out the 8 here, now I'm going to do this over here because I'm going to run out of room if I don't do this fairly quickly. If I take out the 8, I'm going to be left with x squared minus 4. But x squared minus 4 is itself a difference of squares. So there's one more step of factoring that can happen there. X squared minus 4 can become x minus 2, x plus 2. So down here, this is going to become 8 times x minus 2, x plus 2. Now, let's identify the non-permissibles. X can't equal, well, here in this first, in the dividend here, the denominator, x can't equal negative 2. Well, 8's not my problem. But x minus 2 means x can't equal 2. And then that x plus 2 means x can't be negative 2. Again, it's a repetition there. Now, before I go on here, I want to see if there's anything that I can cancel in these individual expressions here. And nah, there isn't. So now I'm just going to move forward and multiply by the reciprocal of the divisor. So 8 x plus 2, x minus 2. I'm not entirely sure why I switched the order there. Kind of did it before I was thinking about it there. Now, have I introduced any new non-permissibles? Well, yeah, I have. X sits by itself as a factor all on to itself there, so x can't equal 0. And then we've got this 2x plus 1 that I cannot allow to equal 0. Okay, 2x plus 1. Which means 2x cannot equal negative 1, or x cannot equal negative 1 over 2. So there's my other restriction here. X cannot equal negative 1 over 2. Now let's see what we can simplify here. We've got an x plus 2 in the numerator and the denominator. That goes away. I have got a 2x plus 1 and a 2x plus 1, and that's going to go away. And then I've got an 8 over a 2, and that's going to leave me with a factor of 4 in the numerator. Now I think I got everything here. So I've got a 4 multiplied by 2x minus 1 multiplied by x minus 2 all over, well, it looks like the only factor that survived in the denominator was the x. So there we go. Now, maybe we can get away with just writing our non-permissibles and being done with it, but we might have to expand that out. So let's just take a look at this. That's going to be 2x squared minus 4x minus 1, so minus 5x, plus 2 all over x. And then I'll distribute the 4 through. So 8x squared minus 20x plus 8 all over x, where x cannot equal negative 2, 2, 0, or negative 1/2. All right, have a look at this one. It says here, the area of a triangle is area equals base times height divided by 2. Yeah, we know that. If the height of a triangle is this expression right here, x squared plus 4x over x squared minus 16, and the base is 5x minus 20 over x, then what's the area to the nearest tenth? Now, I find it interesting that it's asking to the nearest tenth. I'm expecting a lot of canceling to happen here. Let's have a look. So my area is, first of all, going to be that 1/2. Don't forget about that division by 2. It'd be a real shame to do a lot of that work here and get that wrong because we forgot about that. So our base here is going to be 5x minus 20 over x multiplied by x squared plus 4x over x squared minus 16. Now, first thing I want to do is factor. So here, there's a common factor of 5. And that's going to leave me with x minus 4. And here, in the numerator, I've got a common factor of x, and that's going to leave me with x plus 4. I kind of like that. Down here in the denominator, that's a difference of squares. That's going to be x minus 4, x plus 4. Now, you might be wondering, well, why didn't I mean, it's base times height. Why didn't I just multiply that out? And the reason is, if I multiply it out, I'm going to get this really nice big expression, kind of meaty looking expression, but it will be very hard to simplify it once you've done that. It is far easier to reduce when I can first, get rid of any common factors, numerator and denominator, that might be clogging it up, and then multiplying through at the end. So I'm kind of doing this out of sheer laziness. I don't want to go through and do a whole lot of work. Okay? So here, I've got an x plus 4 in the numerator, x plus 4 in the denominator. Oh, shoot, I forgot. I should be identifying non-permissibles here. X can't go to 0, x can't go to 4, x can't go to negative 4. Okay? 0, 4, negative 4. Now, the x plus 4 is cancel. The x minus 4 is cancel. And look at that. Even those individual factors of x cancel. So what's left? Well, the 1/2 and the 5. Well, that becomes 5 over 2. That's just 2.5. And so my final answer here to the nearest tenth is 2.5 units squared, whatever those units are. But again, with the understanding that at no point there can that x be allowed to equal 0, 4, or negative 4. In this question right here, it says when the rational expression x minus 5 divided by 3x squared minus 9x divided by 5 divided by 6x minus 18 is simplified, the result can be written in this form right here, ax minus b over cx. What are the values of a, b, and c respectively? Okay, this is really just about getting you prepared for what could possibly be on an exam, right? This would make your a standard sort of a numeric response on an exam. So let's go work this thing through here. So first of all, we're going to factor. So I've got a common 3x, it looks like, here. When I take that out, I will get x minus 3 divided by 5 over, and it looks like I've got a common 6 there, so 6x minus 3. Now, even though you're not going to have a chance to enter this in the numeric response, I still want to take the moment here just to talk about my non-permissibles. Okay, so my original expression equals this, but my non-permissibles will be that x can't be equal to 0 because of that standalone factor there. 3 because of that binomial factor here. And then that binomial factor gets repeated here. So in fact, the fact that it's repeated is kind of making me happy here because I'm hoping that that will disappear. So I'm going to convert this into a multiplication by multiplying by the reciprocal of the divisor. And notice that that does not put a variable in the denominator, so I don't get a new restriction. Now, what's common here? Well, there's an x minus 3 common to the numerator denominator. There's a factor of 3 that's common numerator to denominator. And that appears to be it. Okay, that appears to be it. And so what I'm going to get here is 2 multiplied by x minus 5 over 5x. Those are the factors that survived. And now I need to make sure that this looks like the form that they want me to leave it in. And if you take a look here, notice that there's no brackets there, there's no parentheses. So whatever had been factored out has been multiplied through. So let's multiply that through. We get 2x minus 10 over 5x. And so now, comparing this here, what are my values of a, b, and c? Well, a is going to be 2. B is positive 10. And sometimes I get questions about the negative here, but notice the negative shows up here. The negative also shows up here. So the b value is separate from that. It's going to be 10. And then the denominator, the coefficient, is going to be 5. And so the answer that you would put on the numeric response would be 2105. I hope that helps. I hope that makes sense.